Okay, so let's start this. How about this? How about we take and we do, first of all, we'll designate the first line, line number 1, and we'll find slope of 1. So remember, m of 1, or slope of 1, is going to be equal to the subtraction of the y values. And for us, the subtraction of the y values, I think I'll do 136 minus negative 53. 136 minus negative 53. And I'll do a negative 14 minus a 7. Do a negative 14 minus a 7. Grab my calculator. So the 136 and the 53 are both positive because that double negative kind of thing going on there. And so when I add that, I get 189. And in the bottom, I get a negative 21. I try to take that number and divide that by 21, and I got 9, negative 9. So the slope of the first line is negative 9. I'm going to go to the second one. I'm going to do line 2. Slope of 2. Same kind of deal, 2 subtraction values. Slope of 2, how about 1 minus 5? That looks okay. And how about negative 27 minus 9? Negative 27 minus 9. Okay, so I do a little bit of a movement. 1 minus 5, negative 4. 27, 9 makes 36, right? And it's negative 36. 4 and 36 cancel. The negatives go away to begin with. So first of all, it's positive. 1 goes into 36 9 times. So I get slope of 2, or line 2, is 1 over 9. These two lines are perpendicular to each other based on the fact that their slopes are opposite reciprocals. And remember that the test is if you multiply 1 times 1 over 9, you'll get negative 1 when you do your mathematics. 2 perpendicular lines always make a negative 1 when you multiply them together. And remember, we called that opposite reciprocal when we did those slopes yesterday. That question pops up a lot, stuff like that you can be able to do that without any calculator or graphing technology. So let's go to 3.1. 3.1 is inequalities. We'll start our inequalities on a number line, and then we'll move ourselves to graphing them pretty soon. But for right now, it's just simply solving and graphing inequalities. Now, you guys have done this before. You've looked at this before. And you should be familiar with all of these symbols here in the center. So let's make sure that we have a notation for those symbols. Remember, when you look at an inequality or anything in math, you always read it from the left side to the right side. So you go from the left to the right, always. So when I read, for instance, 5 is less than 7, I read it in that left-hand side to that right-hand side. It's true that if you go the other direction, that you can have the same kind of thing, that 7's greater than 5. But at the same time, you always read from a left to a right. We can put a greater than or equal to or a less than equal to in the same statement. We use these in things like you must score at least 70% on the video to get to the practice. So at least means you could be 70% or you could be more than 70%. You drive a car on a highway, maybe the speed limit is 75 miles an hour, you have to drive less than or equal to 75 miles per hour. We use words like at most, not to exceed, things like that. Today we're going to bring on a couple of new things for you that maybe you're not used to. Okay? When we move to algebra, we start to talk about a little bit more advanced states of inequalities. We call them intervals, and we'll talk about intervals today. Okay? Everybody got the 4 symbols in the middle? Everybody good? Sweet. Now, this slide is going to be new for you. I'm going to give you a minute to copy this slide down. I would assume that you're very used to graphing something on a number line. Open dot, close dot kind of thing from last year. Well, we have two new things that we're going to add into this. We have one thing we're going to add into this, which is referred to as the interval notation. The interval notation is where the number is allowed to be. The interval notation. We also have this thing called a set notation, and I'll practice writing them all with you today. And the set notation is what we use when we're writing things out. So for instance, if we're making a report, sometimes an assignment, I may be asked to put the item into set notation. And then there's also the graph that corresponds to it with the open dot or the closed dot that you've had before. All of them mean exactly the same thing when we get into a problem. An interval goes along with a set, and a set goes along with a graph. The right-hand side, the type, just simply tells you whether it's opened or closed, meaning is it included or is it not included? Does it have an equal sign or does it not have an equal sign? If your original problem does not have an equal sign, it's always open. If your original problem does have an equal sign, it's always closed. You'll also notice there's an infinity symbol in the interval notation because numbers go to infinity. All the numbers that I see on this graph go to infinity. Some of them go to positive infinity, and some of them go to negative infinity. When we say that a number is less than 4, it can be as small as you possibly can imagine, all the way down to negative infinity. If I say that a number has to be bigger than 10, it can be anything you want it to be, all the way up to positive infinity. Infinity is a whole nother discussion for a whole nother day. So after you get these down, I want to make an example for each one of these so that we have a working example to fit with each one. And once you get used to it, you'll be just fine at it. It's just an addition to what you already know. I'm going to add a little bit of room. Sorry if I went too far. I'll go back. There we go. So let's do a couple of examples. What's up?
So what ones are the braces and what ones are the
Which ones are what?
like braces?
We'll talk about those right now when we do the example. You mean which symbol's a brace and which one? Okay, so a brace, if we talk about just symbols themselves, for instance, this is a paren, right? This is a bracket. And this is a brace. It's that squiggly looking one.
Yeah, but like what ones in the set
We'll do that. You're getting ahead of yourself. Relax yourself. So we're going to crank all these out and we're going to use which one we use with which one. And you can see by those examples which one goes along with them. For instance, certain ones have a parenthesis and certain ones have a bracket, and none of them have a brace on them. So let's do a first one. First example says that we have, if you look at the graph, and that's where I would start by looking at the graph where I am, it says that I have a number, starts somewhere and goes to the right to infinity. This number is heading to positive infinity. You want to put a little positive infinity up here, put it on your graph. That's what it's heading to. Okay, let's come up with that example. So let's say that I have a number line, and on that number line I have a 2, and it's heading towards this infinity thing, and it says that it includes 2. So I'm going to darken this up, I'm including 2, and I'm heading this way forever. You've done that. Okay, let's make the set notation that goes along with that. And I'm going to read it to you. You always start with a brace on a set notation, always. And the variable is the variable that we're messing with over here. So maybe let's say it's x. This little line here says such that. It means I'm about to give you the rule that follows this x that I just wrote down. My x has to be bigger than or equal to this number 2. My x has to be greater than or equal to the number 2. I know it's an equal to because it's a solid dot. Solid dots have equal signs. My interval notation for this. Now, it has to have, on an interval notation, you always have a low and you always comma a high number in that order. Low number on the left, high number on the right. Minimum, maximum, whatever you want to say. The minimum number for me, or the lowest number for me from the picture is 2. 2. The biggest number for me is infinity. Infinity. Now comes the brackets and the braces. If it's got a closed value, closed values always use a bracket. Bracket on a closed value. Because I want my number to be equal to 2. An infinity never, ever, ever gets a bracket. It always gets a parenthesis because we are never equal to infinity. Never put a closed value on an infinity, whether it be negative or positive. We just did all 3 things for the first example. I'm going to switch colors. We're going to go do the next example. We're doing this one right here. I'm still going to infinity, but the difference here is now I have a parenthesis or an open dot. A parenthesis means open dot, and it means not included. Everything in this picture will be exactly the same. The only difference is it's open hole. The only difference in here is that I lose my equal sign. And the only difference in here is that now 2 is not included. Everything is identical except the bracket and the parenthesis change. Okay, and I did that because open hole on the original problem. Do another one. I'll stay where you can still see what we just did. Now this one's going the other way. This one is not going to infinity. This one's going to negative infinity. It's going the other way. It's less. So you should already be able to think about, okay, what does this mean? And I'm going to use 2 again as my example. 2. It's got a solid dot. So since it's got a solid dot, that means it's going to be a bracket. And it's heading out this way. It's going to negative infinity, if I want to put that on my number line. Which means that in my value that I'm writing, now remember what this one's referred to. This one's called the set notation. In my set notation, x is now less than, it's a solid dot, so I include equal to, and it's 2. And I close my set notation. This is just the interval, or this is the inequality that you're used to working with in the set notation. Now, make sure we watch this one. Look up here. You can see that the negative infinity is on the left, because remember, low number left, big number right. Low number in my picture is negative infinity. Remember what I said? Never, ever, ever use a bracket on infinity. 2 is my big number. Put a bracket on it. Try and make the last one for me using 2. Make the last one using 2 for that example right there. So the thing you should recognize is that everything is identical. We're going to use a 2 as the example, and the only thing that changed here is now it went to open hole. So because it went to open hole, now the 2 is not included, open hole. It's still heading in this direction towards negative infinity. It still has an x such that now x is simply less than 2. No equal sign anymore. You can't have a bracket or you can't have an open hole, and they can't be mixed up. They have to be the same. I'm still going to negative infinity as my small number. I'm still going to 2 as my big number, but now I don't include my 2. All 3 of those things say the same thing. And the questions will ask you, make an interval. That's the left-hand side one. Make a set notation. That's the middle one. Make a graph. That's the third one. Give the inequality. The inequalities are all right here. I can see the inequality in every single one of these. In algebra, calc, pre-calc, geometry, we use intervals. We use set notation. Let's do some examples, people. Let's do some examples. So I kind of just did this one, so I'm going to modify this one. Let's make this example a -2. First place, I think that it's probably the smartest place to start. Now it says graph the inequality. I got to graph it, and give the interval. So I got to give the interval. The smartest place for me to start is the graph. If I can see it, I can make it. So I make a number line. I know there's a -2 on this number line right there, dead center in the middle. Okay. I have no equal sign. No equal sign means that my picture has an open hole. It also says that my x's are smaller, which means my numbers from -2 are getting smaller and smaller and smaller and smaller. My line is going this way towards -infinity. I'm leaving -2 and I'm going to the left-hand side. So I graphed it. Done. Check. Second thing is it wants me to make the interval notation. Small number, big number, always small, comma big. Then the question is, what do I put around it? This is never a question. Always a parenthesis. I go to the original problem. There's no equal sign. No equal sign, no bracket. Got to use a parenthesis. Second part done. I have my number line. I have my interval notation. Just for the heck of it, let's make the set notation. X such that. Go find this right here. That was the value. X is less than 2. And this one, you put braces around. This is the set notation. Interval notation, set notation, picture. Now, some of them we'll have to solve and do. But that's the basic part behind it. Go ahead, you try one. Make me all 3 parts. Start with the number line. After you got the number line, then create either the set notation or the interval, but then do the other. So we want all 3 parts when we're done. We want a picture, an interval, and a set notation. And we're given the set notation as an extra, even though it doesn't ask for it right now. People at home, if you want to type something, then type to me the interval notation, because that's easy to type into the chat. You actually also at home could type the set notation, and the straight up and down bar is above the enter button on your keyboard. Okay, looks like a good portion of you have it. Graph goes forever. In the middle, I have a -1. It's got a solid dot because it's got an equal sign. The question is, which way does it go? Does it go left or right? It says my y's are bigger. Because my y's are bigger, they go this way, and they go towards infinity. That means my interval, small number, comma, big number, never ever put anything but a parenthesis around an infinity, and this one includes the -1, it gets a bracket. When I write that out, x such that, I just go over, actually, this is not x such that, sorry. This is y such that. It's always based on the letter in the inequality that we have, okay? So that's a good one to have. Y is greater or equal to -1, and we close off. We use the letter that's given in the original inequality. All right, let's roll it. So in this one, you're given a little bit different information. The graph looks a little bit different. You're not used to seeing what you see, but you should know what that parenthesis means according to our notes already. And you could modify that graph to make it look the way you want, but what we want is we want the actual inequality. That's what it's asking for. I'm also going to give the interval. So we'll give up on the set notation for a little while because that one's easier, just typing stuff. A parenthesis goes along with an open hole. This is the same thing as saying open hole. For us, that means it can't include. There's no equal sign. So it's either got to be a less than or it's got to be a greater than. Well, what we have to look for is where the answers are. The answers are this way. The answers are heading in this direction. They're anything from that number 3 is where that looks like that is at, heading in a right-hand side direction. So the inequality is going to be easy. We'll pick a letter. Doesn't matter what letter you pick. We'll pick X. It's going bigger than 3. 3 is my number that I'm comparing to, and it's bigger, but it does not equal my 3. We don't jump to the 4 because 3.1 is good, and 3.2 is good, and 3.3 is good, and 3.4 is good. Lots of numbers are good. And then if I want the interval, remember, look at your picture. Smallest number I ever see up there is 3, but it never includes 3. I'm trying to go to infinity, and I never include infinity. These two things say exactly what this looks like. We have different places for different ones. We need both of them. You guys go ahead and try that one. Do both of them. Do the interval, do the inequality. Write your intervals. They have to be from the small side to the big side. This one's clearly not going to positive infinity. This one's clearly going to negative infinity. So my small numbers are already negative infinity. Remember, an inequality is about all of the numbers that you can beat, not just the one that you see. You see a negative 4. That just means that's like a cut point. That's a barrier. That's a stopping place. Okay, so I see a bracket, and a bracket's the same thing as a closed dot. Closed dot. So if I had a graph that had a closed dot going to the left, this would be exactly the same graph. It'd be no different. So the first thing I'll do is I'll do my inequality. You always start with your inequality. I'm going to use P this time. You don't have to. My P values are over here. You don't start with negative infinity something P. You talk about, okay, what happens to the P values? They are less than or they are equal to negative 4. That's my inequality. You do not start with negative 4 is greater or anything like that. It's your P values are smaller than that 4. Now you need your interval. Your interval goes to negative infinity. That's your small number. Your interval goes to negative 4. That's your big number. The 4 can be included because it's a solid dot, and the infinity is never included because it's infinity. The minute you think you know infinity, I'll tell you to add 1 to it. Now you have a bigger number. Or I'll tell you to subtract 1 and you have a smaller number. We never reach infinite values. Okay, now we got to solve one. Look what the directions say to do. The directions say solve and give the interval notation. So it's the same exact work. But we have 2 steps. First step is let's do what you've always done before, and let's solve the inequality. And then 2, let's create the interval notation. So the first thing I do is I move the 5, right? The 5's got to leave the negative 2x side. So I subtract the 5 on both sides. I subtract the 5 on both sides. Negative 2x greater than equal to. Take 5 away from there. I got 6, and that 6 is positive. Somebody remind me what happens when you divide an inequality by a negative number? Something special happens. Oh, really? Seriously? Something happens. Doesn't turn positive. I'm not talking about the number. Something happens to the inequality sign. Something happens to that greater than sign. It flips. If you divide by a negative, if you divide or you multiply by a negative number, I don't care what negative number it is, the sign will flip. So when I divide this number by -2 on both sides, x less than equal, it flipped itself, -3. You gotta remember that one. That one's like a big caution right there. That can get you in a lot of trouble if you forget that one. Okay, I need my interval notation because it says I need my interval notation. Think about what this says. If you need to make a quick picture, make a quick picture. Here's what it looks like. Here's a -3. My x's are going to the left. My x's are going this way right here. It's a closed dot, and it's going left. -infinity, -3, include the 3, don't include the -infinity. There's no harm in making the picture if it helps you. And it takes no time at all. And don't forget this, because that's big in inequalities. One more. Ooh, that's a big one. Go solve that one. Go solve it and then write the interval. Don't mess up solving it. People at home, get me an answer into the computer, please. Hey, Ava, I'm going to show you guys a way at home how to type infinity, kind of. So you had the bracket. You had -1, comma. If you do this, you put 2 zeros next to each other, it kind of means the same exact thing. When you guys are in My Open Math and you're typing, the shortcut for infinity is 2 zeros right next to each other. I think it's zeros or O's. You got to look at My Open Math when you go there. It'll tell you how to shortcut to infinities. Let's see how that looks if I type it differently. It kind of looks better with O's, actually, to tell you the truth. So use O's instead of zeros. It looks like a little infinity symbol. And My Open Math takes that as a shortcut. And I think it is 2 O's. Check it out when you get there. You should be close to solving already. And it shouldn't take anything to make the number line in the interval. Watch your distribution. Remember, you got to move terms. I'm waiting to see who at home gets to answer first. You got a Kit Kat bar. I'll shove it through the camera for you. All right. I see a bunch of pens down. 3 times 2, 6x. 3 times 4, -12. Keep the 4x. There's pair like terms. 3 times 4, 12x. 4 times 7, -28, plus 8. I have like terms on the left. The like terms on the 6 and the 4, which make a 10x. -12. This is no different than an equal sign. You always completely solve the left and the right before you go to the left and the right at the same time. On the right side, the only x I got going on is the 12x. I got a 28 and I got an 8. That's going to make a -20. You can move the x to whichever side you want. If you want to keep it to the positive side, keep it to the positive side. It doesn't bother me to have a -x. So I'm going to move 12 here, and I'm going to add 12 here. Right? Because I'm moving the 12 to the left, it goes negative, and I'm moving the 12 without the x to the right, it goes positive. 10 minus 12 is negative 2x's. Keep that sign. I did no division yet. 12 and 20, negative 8. Here comes the sign flip for me. Divide by negative 2, divide by negative 2, x stays here, flip to greater, 9 goes to positive 4. 8 divided by 2, 4. You got to write it the other way, because remember, we're not solving for 4. We're solving for x. X always goes on the left, so you got to figure out how to spin that around. Yeah, this is not an acceptable, let me write down what you just said. This is not what we were looking for. I agree it equals the same thing, but we weren't solving for 4. We were solving for x. Okay? What do I need? I need an interval, right? Okay, if you need to make a picture, make a picture. Number line's got a 4, open hole, because it doesn't have an equal. It's bigger, so it's going this way, going that way. So my interval that needs to go with this is small number, comma, infinity. Don't include either one. I need both of those in my solution. All right, let me stop my video so that I can get the rest of the stuff that's going here. So give me 1 second. Let me stop that bad boy.